man, what are you doing?
Can't get my weights filled properly, Mike, and my forces are not consistent. My tablet weights aren't consistent.
What are you doing with your mallet?
Well, there's some bridging going on right here.
Yeah, let's see the bridging. I was going to see it.
I think I have some rat holding too. I don't know if you can see that.
Yeah, look at that rat hole, and that's terrible.
Yeah, so that's why I'm using the mallet, Michael. You know, I got to do what I got to do to get this to work.
You're trying to get the powder to fall into the feeder there is what you're doing, huh?
Yeah, you can see the paddle in you can see the material in the paddle feeder. Let's take a look at the AIM software here and see what we can do. Oh, boy. I got to increase the feed. Let's slow the turret down. Let's slow it down to 20 RPM.
So your feeder speed's at 5 RPM and your turret's currently at 20, huh?
Yeah, my feeder, let's go up to 20. I mean, that's faster than I like. All right, now the feeder's starting to move. I might need to get that mallet back out here. Hold on, let's still have.
I see the bridging's gone now. It seems like it's dropping down.
There's the bridging.
Oh, there it goes again.
There it goes again. Let's get the mallet out.
The powder is not flowing. Nope, it's doing it again.
We got a rat hole problem.
Yeah, I'd say you have a rat hole problem.
Yeah, we got a major rat hole. All right, let's see what else can we do here. My forces are.
Go back to that software.
Let's go back to the software. It looks like my main compression forces are looking pretty even now. So it looks like I'm fixing the problem, but I still have that bridging.
I bet you let it run a little bit. You're probably going to go back to low forces again and uneven forces across each compression.
Where's my dosing at? I'm at 15.88 millimeter dosing, and I've got a fill cam of 18 millimeters. So that looks good.
I can increase inconsistent weights right now, is what you're saying.
Yeah, I'm going to increase my dosing cam to 16, 17. Let's get the mallet back out here.
Yeah, your forces are jumping again there. It looks like you're running out of powder.
I'm not, though. It's just bridging. Yeah, there's the bridge again. See if I can get that rat holing away. How's that looking?
Oh, it looks pretty bad still. I could still see a big old hole in there.
Oh yeah.
I don't think this powder's going to flow, Robert.
Yeah. So let me stop the press here.
What material are you running?
I'm running MCC and dicalcium phosphate.
Yeah. What percentage of each are you running?
I'm running a 60-40%, 60% dical, 40% MCC, but I also have a little bit of mag stearate here. Let's go through the process here. Welcome to episode number 2 on dye filling.
Yeah. So in case everybody hasn't wondered, we are on dye filling this week, and obviously what Robert's presenting as an example is something we kind of created in the lab to help everybody understand, a scenario that you could potentially run into. So these are, examples of real life scenarios. We took something that we found a customer doing, and we're now replicating it here. And we're going to let you, at the end, when we go into questions, we're going to let you see if you can figure out as the audience what the issue was here with the powder and why it's not flowing properly. But to get us started this week, so this is episode 2, we're talking about dye filling and what is a dye. So if you remember last episode, we talked about what a dye is. This is a really big dye, but everything that you're doing on that press, Robert actually has a regular size B die there. Everything you're doing on that press is trying to get powder into this little hole here. And the reason why this is potentially difficult in this case is everything to do with how the powder makes it into the press. So cheap part, simple design, one of the cheapest, but a lot of time, a lot of effort, a lot of expense goes into this. So here's the die, and then right above that, Robert actually has it in his hands there. Right above the die is the feeder, and you can see that feeder tray there, and there you go. It's basically passing underneath the feeder, which we'll show you here in a 3D example. But those are the paddles and everything that we're looking down there with the camera. So to start us off, Robert, let me bring up our.
Yeah, let's go through the process here.
Yeah, let's bring it up. And you start off with our hopper.
Yeah, so again, this is the hopper. This is where we saw the rat holing. So let me show you another image over there.
Okay, so there's the rat holing.
Now this is a mass flow hopper, guys. So this is a well-designed hopper. It's a mass flow, so there's not any sharp kinks or angles where the powder needs to flow through. So it's all nice and even. And then the diameter is over 19 millimeters. It's actually probably about double that. So anything less than 19 millimeter hole is pretty small. So we like to be larger. So that's the hopper. It's designed properly. We've got a shutoff valve on this hopper, this particular one.
Yeah, so everybody that can see here above me was actually a 3D example. Thank you to Natoli for preparing this. So the hopper design sits here in the top. That's what Robert's showing you. So this is basically the press, the RD30 you're looking at, just without the case around it. So that hopper is there on the top, and then it flows down to that shutoff valve, and then here's the inlet that Robert just showed you.
Yeah, so this inlet here is actually, it's a clear cover so we can see what's going on inside. Right now you can't see it, but there was bridging going on before. But now it seems like the powder is flowing through it into the feeder.
Yeah, if we started the press again, we'd probably get right back to the bridging, because as those feeders start moving it into the die and it starts consuming, we'd probably see the bridging again. But this clear lens allows you to see that. So the example that Robert had in his hand there of the feeder is what you saw here. Now, if you kind of hide some of these parts, you can see within it that the next phase, so it goes through the hopper, right, into the inlet, and then there Robert has in his hand, those the feeder paddles, right, and there's the die. And then if you look here on the 3D example, you'll see that this is the die back here. This is that feeder opening here. Okay, so that's the feeder pan. That's the opening you're looking at, that green outline over the die. And then here are the paddles. And those paddles is what Robert was spinning there.
I can spin them right now.
Yeah, so Robert's going to jog the feeder, and you'll see there on the eye. Let's bring that up in full screen 1 sec, Robert.
Yeah.
So you can see those paddles there are spinning, and those are what is actually agitating the powder and pushing it into the die. And those are the different components in this simple setup that are getting powder into the die. So that's what this is happening here. So right above this paddle was that viewing window, and it is help push items or powder into the die. Now something else which is below the turret that helps get powder, in this case, into the die, which we'll explain another serial in a second, is the fill cam. So Robert, you want to kind of show us on screen here the fill cam? I'll bring that up full screen here.
Yeah, sure. Hey, one thing I want to mention about the paddles, Michael, is the paddles rotate to aerate the product. It allows it to flow. So it's not pushing powder in the die, it's allowing it to flow. And as the die comes underneath the opening of the feeder, gravity allows it to fall, and that fill cam vacuum. So it's not really pushing powder in unless you're using the plow design.
Yes. Good distinction, Robert, there. That was a terminology mistake on my end. We do not have plow feeders in this setup currently. So right there, what Robert's showing you is the fill cam. Robert, you want to point to it? There we go. All right. And then what's to the left of that, Robert?
Well, to the left of it, this is actually your dosing cam. This is what you're going to adjust to adjust your tablet weight and your fill volume. So the fill cam is fixed. It's going to pull down to 18 millimeters, and then the lower punch, which actually here's the lower punch, it's going to ride up this cam and push up to right now, I believe I'm around maybe 16 millimeter. And then the excess powder gets pushed out, and the scraper bar scrapes it off and directs it to the center groove of the turret. And then it recycles back into the feeder, and the scraper bar is right before that tail over die.
Okay, all right, so let's see that in 3D space here to kind of get a better representation. So what Robert just showed you was the fill cam, which is here highlighted in green, and then the dose cam or the weight cam. So let's see how that works. If we kind of make this transparent, we'll see there's actually a groove inside that part that pulls that punch down. And there's a significance of why we want it to pull the punch down right below the feeder opening. Okay, so here it's pulling it down, and then the weight cam or the dosing cam is going to pick the punch back up to ride off into the scraper bar, which is what Robert showed you here. And that's what gives you the dosing or the weight of the powder in your die.
Yeah, this scraper bar is spring loaded and it's designed to scrape that material and push on the turret. When this scraper bar gets worn, you replace it. It's an inexpensive piece. You replace it when the spring loaded scraper has been worn. This can cause issues with powder escaping the feeder, getting on your turret, making a mess, having yield problems. So this, again, is your spring-loaded scraper bar.
Okay. All right. So we kind of covered how we get powder into the die, but let's cover a specific scenario, Robert, if we want to go back over to the classroom here.
Yeah, let's go back over.
And then I will bring up we're going to go over their compression cycle first, and at the end, we're going to go over the common root causes of tablet manufacturing as the last 5 steps. So to start us off, let's go over our compression here. Share my screen. All right.
Yeah, so the common root causes.
Hang on one sec, Robert. I'm sorry.
Yeah.
I started on the wrong slide here. All right, there we go.
So we covered the five reasons for manufacturing issues, Michael.
Oh, I think we're going to do that right at the end before we start asking questions. That
Okay,
kind of
very good.
Whether or not anybody understands what this problem was root cause from.
Yep. Okay.
Okay. So to take us off, we have our filling and volume adjustment, which is what we just covered. So we're trying to get powder into the die, which is what you see here. But Robert wants to make sure we cover a very distinct difference between powder design, flow design of powder into your die. So Robert, you want to explain what's going on here?
Yeah, so these are 2 different examples of how tablet presses are engineered. The one on the left is an older design. If you go to Wikipedia and you type in tablet press process, you will actually see this on the left. And if you take a close look at where the fill cam is, it's pulling the lower punch down, and the clearance in the die is tight, and it creates that partial vacuum. It's supposed to suck the powder from the feeder into the die, but in this example, notice the fill cam is pulling down, but there's no product going into the die. That's because the fill cam is designed to be before the opening of the feeder. This is actually a flaw. This is a tablet press flaw design that we've corrected with new machines. If you look at the image on the right, you'll see where the fill cam is pulling the lower punch down, product is going into the die because the opening of the feeder is located right above the fill cam. So you need the fill cam to pull down and pull powder in, and it needs to be located where the opening of the feeder is. So the one on the left, these are real machines. I'd say 20, 30% of machines out in the industry right now are operating like the left. Those machines will limit the speed that you can run your turret. So you have to slow the turret down to fill that die properly. The image on the right there, you've got proper engineering and you're filling the die properly. You can run those presses much faster, and the faster you run, the more pull down you got and the more vacuum effect. So it actually can suck the powder better at higher speeds. So again, the one on the left, this is a real design, but it's an older machine. The one on the right is the newer designs where we identified you got to pull the powder out of the feeder at the fill cam stage.
All right. So how can you identify this on your press to make sure you're equipped with the right technology? And to be clear, you can adjust how the design is on some presses if this is not the case for you. So what Robert's showing there in that example, here we have in a real life example, and what you're going to be looking for is here's your bottom pan of your feeder. That opening here, all right, that feeder opening should be under where the drop of the cam happens. So here's that drop. That drop needs to happen within the feeder fill window. Okay. And so if this is set up in this manner, then you're set up in a way that it'll actually draw down and actually vacuum into the die. If this drop happens before the opening and the feeder starts, then you're set up in a method that does not help you bring powder into that die. So there's two different styles there. And yes, we're bringing this up because there are several people with older machines on the market that we continually assist and help today. Okay. All right. So that brings us to our next slide here. And we're going to talk about we're going to re-highlight the 5 common root causes. Robert will bring us through each one, and then we'll kind of go into our questionnaire where you'll cover what led us to this, Robert, and then see if we can have the audience give us feedback on why this may have occurred.
Yeah, so when trying to identify root causes of manufacturing challenges, we look at these 5 things. So back in the lab, we were having weight problems. The forces were all over the place. So is it an operator training issue? Am I a good operator? What did I do when I had weight problems? Well, I was adjusting the feeder speed, making them faster. I was slowing the turret down to get more feeder fill time into the die. I was increasing the dosing cam to get more volume in there. So operator training. I make sure you had to adjust the machine properly. I even had the mallet too, so I understood I use that rubber mallet's gonna get that power to flow and get rid of that bridging.
Anything you can come up with.
Yep. So operator training. Number 2 is equipment conditions and design. For example, is the fill cam pulling down under the opening of the feeder? Well, on the RD30 and the Tolly design, yes, they do pull down in the proper position. So the equipment condition design is good. The environmental controls, we're less than 40% humidity in our lab, temperatures controlled, so that's not a concern. Process engineering, were we granulating and milling, and maybe we were milling improperly or granulated, the material's still too wet. This was a direct compression blend. All it was dicalcium phosphate and microcrystalline cellulose with a little bit of magnesium stearate. So that brings us to the formulation. Maybe it's a formulation problem, but I am using common excipients, dical, MCC, a little bit of lubricant. So somewhere in those 5 there was the problem. Let's see, maybe the audience wants to join in here. I don't know how much time we have left, Michael, but is this a good time to open it up and go live with some questions and comments?
Yeah, I think so. I think before we do that, what I want to mention is, hey guys, next episode we'll be continuing die filling, because there's a lot of different mechanical components that we want to go through on aiding you getting powder into the die. There's different designs and concepts that you can do to maintain head pressure, change out paddles for different various issues you get to with powder. We're going to be joined by a gentleman named Randy Jung. He's also from the Tolly's team. He's very versed in powder and press engineering and why this different series of parts and components will be utilized to offset some powder properties that you're trying to get around, and some techniques and tips and tricks. So that'll be the next episode, which will be next week, Tuesday, and we'll schedule right after this. So be sure to sign up and join. Okay, so with that, what did we do wrong in this? Does anybody have any idea what we did wrong?
Okay. How much time are we at here, Michael?
We're just hitting our 10-minute window for Q&A.
Okay.
So let's see what we got here rolling in. Okay, so while we're waiting on questions to kind of come in, just so everybody understands, to make this show successful, we want to bring in obviously a lot of the new people in from the industry, or if we have interns, even college grad students, we want to bring in more and more people to help give this knowledge to. And by doing so, it requires us to ask you for help in sharing our content as well as the link here to bring people into this free training that we're offering. Everybody's here helping host, creating the content for you to carry you through common problems with tableting. And obviously weight issues are a core piece to that. And we'll make sure we cover this exhaustively. But we could really use your help in doing so going forward by sharing our content on LinkedIn as well as the page, getting people to sign up, and then joining the live sessions, getting the new people involved in your teams, If you have some younger individuals on your team, please bring them in, as well as some of the people who've been in the industry for a while. Maybe you'll learn a couple things here and there. But please join us and help share the wealth of knowledge we bring to this podcast.
Yeah, I'd like to also add, we're going to have some special guests, like Randy Jung's coming in next week, but we're going to have other special guests coming in, because what we plan to do here is to go over the whole process. Right now, we're focused only on die filling, right? There's a lot to be said with die filling from an engineering standpoint, from powder characteristics, environmental controls, again, operator training, and machines running properly. So we're starting there, and then we're going to go into the different compression stages: pre-compression, the proper way of using it, the right amount of pressure. Do you need pre-compression? Then we're going to go into the main compression. This is actually where you're deforming and fracturing the particles and forming the bonds. There's a lot to be learned there. The compaction physics, compaction simulation. Also like to mention that we're getting ready for the compaction simulation forum. Actually, Michael is one of the speakers there. We're going to talk about compaction physics. Really, really good get together in Lisbon, Portugal. But there's a lot to talk about there. Then after compression, you got the decompression stage. This is where capping, delamination occurs. Then you got the ejection. Why do we add magnesium stearate? To satisfy the ejection. We misuse magnesium stearate. So we're going to identify what is the proper amount of using that lubricant. There are other lubricants available. We're going to talk about all of that. Then you got the takeoff. You got sticking, picking issues. So we're going to identify how to resolve these. The most common manufacturing issue out there is picking and sticking. So we're going to go over all these different steps, and then we're going to have even more episodes after that. So we appreciate you guys coming in and joining us, and giving us some feedback as we continue with this.
Yeah, and if anybody's curious, after we air each episode, it's actually forever on YouTube. So we have a channel out there, and you can always go to it, watch these, rewatch them, make sure you've collected the content you're looking for. And then if you do need help, we do help different people in the industry with different issues. So we have a help service you'll see here on the banner. We're Dr. TaBlitz. You can get our assistance, our technical expertise, and we have resources across the industry with any kind of problem. If you do find something that you can't solve and we haven't covered it on how to approach that problem, you can feel free to reach out to us. We do help industry solve different various issues all the time. So far, Robert, we haven't had anybody comment on what exactly was the issue with the powder flow today. Let's, do you want to kind of explain what you did to set that issue up?
Yeah, we actually have a graph to show you here too, micromeritics graph. But basically, I'm using one of the two most common excipients in direct compression. Right? I'm using dicalcium phosphate, which is known for its flowability. It fractures in a brittle type state. And then microcrystalline cellulose, which is a very strong plastically deforming material. The combination of these two makes a good kind of placebo, and some magnesium stearate. The problem is which grade of materials that I use. The MCC, there's a 50 micron grade, and there's a 90 micron grade, and there's other grades as well. So I used a 50 micron grade, and I blended that with dicalcium phosphate. The bulk density on this microcrystalline cellulose grade was like 0.15 grams per ml, very light. The dicalcium phosphate, I don't even know, 0.85 grams per ml. So big difference in bulk density. And I did a 60-40 ratio blend. And you can also see what you brought up there, Michael. This is the particle size distribution curve, and you can see we got a bimodal curve here. We got a lot of material in that below the 75 micron sieve, that's the pan, and then it got, it drops down at the 125, 150, and then it peaks back up at 180. This is your dical up here, that 180. So your dical, most of that is that 180 screen, and then the zero there, that's your MCC. So you got a disparity in the particle size and the bulk density. You can't mix these two together and expect a good flowing product. So that was the root cause. It was a formulation problem, guys.
No, I mean, that's perfect. We actually have a comment here from Mahmood. He said, formulation problem needs a glidant to overcome rat holing. Yes, the common thing sometimes people go to is to add material, but sometimes looking at the ingredients you already have first might actually lead you to a better answer. Where in this case, Robert intentionally put the wrong grade of MCC which is normally used for granulation. But yeah, and in some cases, the glidant is required. Robert, you want to speak to that any further?
Yeah, I mean, that's a great answer. I mean, using a glidant, 1% or less in your formula always help you with that flowability. So it would help us. Would it get rid of that route holding? I don't know. It's just that big difference between the bulk densities and particle size was the major problem there. But yes, good answer. Adding a glidant is definitely something you can do to help with this route holding problem.
All right. And a good question just came in from Anka. I'm not going to try and pronounce her last name because I think I would not do it justice, but how would a very heavy tablet occur overfilling a die? How would that happen? So I think what you're saying, Robert, is the tablet is much heavier than she would expect based upon her dosing cam height.
So how would a very heavy tablet occur overfilling a die? How would that happen? So the way that would happen is the example I showed you in the lab there. I couldn't fill my dies properly because I had rat holding, bridging, flow problems. So what did I do? I increased the dosing cam, right? And if I used that rubber mallet and I kept banging on it and then the powder started flowing in, now I overfilled the die in the dosing because I just kept increasing the dosing cam to try to fill my powder in there. And when you fill the powder in there, now you got a full fill. And this is where you can cause problems then because my tablet thickness, I didn't change. This is where you can over compress and cause overloaded tooling, capping issues, delamination issues. So getting a heavy tablet mistakenly is by having flow issues and increasing your dosing cam to try to get that powder in there. And all of a sudden you got a full fill of powder going in there and it fills the die 100%. Now you have a heavy tablet. So that is an example of how that situation could occur.
Yeah, great question. Thanks, Robert, for the input. So again, this is the importance of making sure your die is filled properly. And this is just another symptom, which a lot of people are experiencing many symptoms, and the same root cause is getting powder into that die consistently and appropriately each time it goes underneath that feeder.
Yeah, and, I make another point here, Michael. So I mentioned this before, but a lot of your tablet defects, the root cause is flow issues. So like that example, the heavy tablet that Anka asked about. So if you overfill your die, your your roller positions are fixed unless you physically adjust them. So if you have a fixed thickness and you overfill your die, now you overcompress and you have that capping issue, delamination. And then let's say the powder doesn't flow properly. Now you've got a low weight. Your thickness is still fixed, and now your force is really, really low. This is where you might get sticking problems because the particles aren't bonding to each other because you don't have enough pressure and bonding pressure. So it adheres to your punch face. So a lot of times these tablet defects, the root cause is because you're having flow problems and weight issues.
So Anka had a follow-up question. She said, basically operator error. Yes, could be, but also could be formulation related, right? That could be the root cause.
Yeah, it could be a combination. So an operator error, a good operator is going to know, hey, I've got rat holding. I've got bridging. Don't keep filling up your dosing cam because you know eventually that powder is going to push in there once the rat holding goes away and you can damage your press. So I kind of agree. It could be operator issue. I mean, the operator should identify, I've got rat holding, I got bridging, my paddle feeder is starving of material. I know I shouldn't be increasing that dosing cam. I got to fix the root problem, which is the flow, which is the formulation. So it's a combination. So yeah, I agree with you. Operator error would be a cause because they should have been aware of the rat holding and the bridging.
So Mahmoud has another question here. So when we want to know the real causes, should we check these causes in order or just do it randomly? Like we must check the operator first and then go on with the list in order. I think that's going back to here, and I think that problem that depends.
I have an answer for that.
Go ahead.
So Michael, I mean, you and I see this all the time when a customer is running production and they look at their C of A and go, oh, nothing has changed. Let's make 500 kilos of this blend and let's put it on the tablet press. You should be doing some simple quality checks, micromeretics. That PSD graph that Michael shows you, you should be looking at that. You should be looking at the bulk density and tap density. If you want to do something real simple, just test the bulk density. and the tap density. That requires limited material, not much effort and time. And if you see a difference in bulk density from one batch to another, there's a red flag. So you can do a little bit of homework before you get to the press to make sure that what goes in and you expect to come out. So, you check all your raw materials coming in and make sure they're within we call it the gold standard, right?
Yep.
Make sure it's within those specifications. And if it's outside those specs, you got a problem. So you're checking the formulation. You look at process engineering when you're doing milling and granulation. Check the micromeritics and see if the particle sizes are where you expect them to be. Is the bulk density where you expect it to be? If it's not, then there's a red flag. So I would probably start there. But there's other things. Obviously, you got environmental controls. Your lab needs to be within, certain humidity and temperature. Your equipment. Okay, let's talk about that fill cam where it's pulling down under the feeder. Do you know if your press has the right design? That's something that you can take care of right away. You should know right away if you've got that problem.
Yeah, that carries into other things as well, right? So if you have inter-process controls, right? So if you have to go to milling or blending, every time you change something into your powder, you're trying to do something to it, trying to add something to it, you should probably have an idea and a pulse check. Like Robert said, that bulk density, tap density, particle size distribution at each of those steps, setting that gold standard, knowing what your quality should be out of that, right? Once you get something that's successful, how do you monitor it? How do you pulse it? So to this question, where do you start? Well, if you set up your standards along the way, and if you need some help, reach out to us and we'll kind of help you guide down that path. But if you set up your process in a way that each time you can go back and say, okay, where did the powder change? Why is it different than what we did last time? Set up those pulses, and that way you know where to start looking. Instead of change, first thing you do is not change a bunch of press settings until you've gone in circles and a lot of material wasted. Check your quality attributes at each interval that you've collected and see where the deviation is. So, all right, we are at time. We're actually 2 minutes over. So closing statements again next week, Tuesday, same time. We're going to go over the phase 2 of this. It'll be more mechanically driven. We'll have Randy Jung as a special guest joining us from Natoli Engineering. We plan on covering the same flow, but with different mechanical instruments that you can use for particularly difficult powders. So that'll be next week's episode. Robert, you want to say anything before we close it out?
No. Thanks for joining, and we look forward to see you next week. We're doing it real quick here. We're only 7 days in between, so you'll see us soon. So thanks for joining in.
Yes, we appreciate everybody's time today, and we will see you next week for the part 2 of die filling.
All right. See you next time.